Okay, so this is about educating T-shaped software-intensive system engineers that basically say it works out best if somebody is deep in one discipline but is not I-shaped and they're only in that. They're also getting a working knowledge of hardware, peopleware, economics, finance, medicine, whatever kind of application that they're doing. When I was at TRW, I was fortunate to get involved in a couple of initiatives with Simon Ramo, and one of the things that he had learned from his experience at TRW was that their best TRW engineers were T-shaped. So they were strong in at least one technical discipline and had working knowledge of other success-critical disciplines. But fundamentally, what we found, what we hired every summer or fall was a bunch of I-shaped computer science graduates or software engineers. And so basically, when I was getting ready to either early retire or spend another 10 years at TRW, well, it would be worth trying to figure out a way to create T-shaped software engineers. And so I went to USC and put together a master's in computer science with specialization in software engineering that had a number of key courses that included software and system architecture, user interaction, software and system test and analysis, software management, and economics. And the basic thing that put it all together was a 2-semester real client project course where the students would form into 6-person teams and get mated up with a person who had some software that they wanted built for them. Some of them were campus people that wanted their fine arts slides organized, and other ones in the medical school that wanted their lung pathology slides organized, or their age blood samples barcoded, or things like that. And so what we basically decided to do was not to do this as a capstone at the end of their master's degree, but to do it as a foundation stone and say, we're going to throw you in the water. Here's this client who doesn't know anything about software, and what your job is to go find out what they're doing, listen, have agendas for your meetings, have meeting summaries at the end of meetings, and fundamentally the fall semester was focused on software-intensive system engineering. So they would have to work with the clients to determine what is an operations concept. What are you unhappy about with your current way you're operating? How can software help you do it better? We have a 6th-generation requirements negotiation tool where we finally found something that was non-technical client-friendly, which was a Facebook-oriented approach to negotiating requirements called Winbook. Some of the team were doing prototypes, some were doing architecture, some were doing lifecycle plans, and in general, the manager of the project was doing something called a feasibility description that said, now, here's how all these ops concepts and requirements and architecture are going to fit together, and here's the evidence that it's key. And basically, yeah, we've put 2,000 students together to date, and we find that they are a good deal more T-shaped at the end of the process, and that they generally do better in job interviews, they do better in their future careers, and things like that. So that's one educational approach. Again, there are a lot of other ones like it. I think the CERT STEM programs that get people in mechanical or civil or electrical engineers to go in and do a project for some defense organization or things like that is a similar example, and there's quite a few other ones. One final thing is that too many projects are triple I-shaped, where you've got I-shaped hardware people, I-shaped cyber people, and I-shaped human factors people. And again, they know a lot about their own thing. Their hardware people's underlying science is physics, chemistry, continuous math. The software people is discrete math, logic, and linguistics. The human factors people is physiology, behavioral sciences, and economics. And unless they understand a little bit about what each other comes from, they tend to push for the wrong kind of system decision. Major lifecycle cost sources, the hardware people feel that the more you produce, the cheaper it gets per unit. Software people have found through bitter experience that the more software you produce, the more expensive it gets per line of code. So again, I will stop there, but I think there's a bunch of things like that in here that are of concern, and I have some concerns about the way some computer science departments are going. We have to teach people so much about big data and agents, we could get rid of calculus.
All right, thank you very much. So, first thing I would say is what he said. It's very much where my head was at when I thought about the remarks I would make. My net is that we need people who look at problems end to end, and that needs to be part of their. Should I have a microphone? Or? Okay. So we need people who work problems end to end, and they need to do that. They need to think from a systems engineering point of view, but they need to be deep to start deep in a particular area or technology. And so where I come from on that is, I started my career in the defense industry where we had engineering that were this thick. I ended up in the commercial world, in particular in consulting, where we were doing lots of very complex projects, but there was no concept of systems engineering. And so we would have, I ran a lot of the delivery of those things, so I was always finding where the problems were, and it was usually people had built something that didn't work, or it was one case, people had built something that worked, but it wasn't what the client wanted, in one way or another, it hadn't been thought through end to end. So one of the things we did was I pulled out that big manual I had from my defense industry world, and we brought it into IBM, and we started talking about system design reviews and things like that. And we actually started a system engineering department. We got some help from Stevens to help us train some people. But what we found out was that over time, the best way to make it work was to have it kind of built into the culture of the way people think and work, versus having sort of an overarching system engineering regime or discipline or something. So over time, those system engineering milestones, system design reviews and so forth, all got renamed and reshaped and put in different places, but it was essentially the same thing. To make sure we set expectations in our team and with our clients as to what we were building, and that we constantly reviewed those and dealt with changes as we went, so that when we got to the end, we actually built something that someone wanted. It worked, and someone wanted it, to do what it was built to do. So I was very happy to be part of the education panel here, because I really believe that has to be built into the educational framework of all the disciplines in order for people to come out of a university setting and into industry with that culture kind of built in. So that's kind of my net of it. And again, it's what Barry said. So.
So Rick, I hope to keep us on schedule. The way some people pronounce it. But yeah. So I actually have lots of questions. I have far more questions than answers, so this is probably not so much a position, but a platform to ask some of these. So some of the questions that come to me, why are we doing this? Are we attempting to align objectives, methods, processes, and tools across divergent contexts and cultures? No. Who's being educated when we're doing the educational process, and what are the different domains that we're trying to educate? What are the skills and the capabilities that need to be acquired? How will the education be accomplished? When is this going to be done in the practitioner's life cycle? And I've got some slides and some questions to ask about some of this because, for example, the context that I come from, I think, is different than the context that other people come from. And putting together, an educational program, to me, we really need to put something together that sort of serves, all the different domains that are there. So, what's the role of a systems engineer? Is this the role, of the systems engineer? Is it the mature adult in the room, which, probably in NASA, in the 60s, when the average age of the engineer was like 20, you probably had to have someone like this, or that bird was not going to fly. Or is your notion, much more of a coach? Is it somebody that's going to sort of help people, through the process? Very different views. You can imagine that if this is your view of a systems engineer and systems engineering, this may not play so well to a group of software engineers, who like to be, chaotic. They like that sort of notion of things. So it's really a question of when we talk about systems engineering or systems engineers, what types of roles are we talking about in that space? What's the scope of the types of projects or the types of systems that you're building? Is it a design to specification? The customer wants this thing, it looks like this, make it like this. And any deviations from that is a problem. Or are you designing something, to a marketplace? Or are you designing, to something for sort of dedicated capability, or is it designed, to be a part of a system of systems, and so it's a flexible type of capability? So each of these have different sort of scope, which is going to stress, systems engineers and people who are looking at it from a systems perspective in a very different way. So, for me, seeing value-based engineering or model-based engineering, I can't see how that's controversial. I just, to me, coming from my context, this seems like, of course, I don't know how you do engineering in any other way than this, but it could be, my context, in my career was in computing, was in, sort of product-based, and it was drilled into my head as a manager of engineering is that the value of the non-recurring engineering was proportional for us to the gross margin we had in our product. So if our product had a gross margin of 55%, we were doing well, good job engineers, and if our gross margin was 3%, they were going to get rid of us because we weren't creating any value. So as engineers on the team, they knew that if we slipped the deadline by 6 months, our product would not be competitive, we would not sell any, there may not be a next product. And so there was a big time focus on schedule. They also knew that the cost of the product was critical, and so the engineers were stingy, and believe me, they focused on cost. So, at CSUN, there was someone from a government agency said, the engineers don't care about cost, they don't care about this, they don't care about that. And it's like, well, if the value of NRE is equal to the cost of NRE or proportional to the cost of NRE, that's probably not something that the engineers are hearing about. They're hearing about billable hours, they're hearing about, how much the software package is going to cost. It's all about cost. If you're focused on value and you know that, your pay and your organization is dependent upon, gross margin, which is, how much value are you adding to this stuff that you're manufacturing, it takes you to a very, very different place. And so you can imagine how, someone who is a systems engineer working in this place could have a very different view than this place. The same with software engineers or engineers in general. So I think it's very context dependent in terms of where you are and how you're working in terms of how you use, systems engineering and engineering. And where are you, on this chart? Are you working in this space? Are you working on network intensive applications? Are you working at the enterprise? As you sort of migrate up this path, you have very different needs with respect to systems engineers. I mean, if you are responsible for a product or a system, and you've got this huge range of stakeholders, and nobody agrees on what it is that you're actually trying to do, you're in a far different place than when you have a very good idea. This is the thing that we need to develop. This is the very thing that we need to implement. And so the types of systems engineers that you're going to be educating in this space are very different than ones that you're educating in this space. Same sort of thing with respect to time. You know, are you working on platforms that are going to be around for 70 years, or are you working on applications, you know, that may have a life expectancy of 3 months or 6 months or something else? From my perspective, I tend to not like to think about systems engineers so much because each company can have a different title. And what is a systems engineer in one place may not be a systems engineer in another place. But really like to think about systems engineering. And I believe that systems thinking is a set of skills that should be used by many in many different domains and disciplines. I think systems thinking, they're a set of skills that every decision maker should have a handle on. I think that systems engineering is a discipline that should be used by many. My personal belief is that anyone in engineering should have a sense of systems engineering, some rudimentary systems engineering skills, at least awareness of systems engineering. And then I think systems engineering as a career is really a very small number. Now the problem is that if we don't do these two, this systems engineer is going to be in a world of hurt because they're working in an environment where no one understands the sorts of concepts and sorts of things they're practicing. And I think we really have to do, you know, all three of these. So in my view, all software engineers should have gone through some sort of systems engineering experience. I think, you know, Barry's point, going through that practice is critical because if you don't do it there, they're going to have to do it when they get out in the outside world. And it can be, you know, it basically puts somebody in a different type of career track, whereas if you can do that immediately, you're way ahead. And I think having that an experience where even if they're not going to be the systems engineer, to have that experience and have an awareness of that is a huge, huge benefit. So we're actually developing a program on embedded systems engineering. And in embedded systems engineering, the teams tend to be, you know, fairly small. There was a survey, and I'll show some results from EE Times, and the average team size was around 15 people or so, and that was hardware people, software people, you know, integrators, testers, you know, and that sort of thing. And one of the challenges they have is they have hardware engineers, software engineers, and they have system engineers as well, but the teams are very small. And so it's important that the hardware engineers and the software engineers have a sense of system. You know, you can't really have these teams of 12, 13, 14 people, and there's one person who has a sense of system and expect that everybody's going to be making the right trade, you know, for that system. And so really believe it's critical that everybody here has gone through the type of experience, you know, that Barry's talking about, so that they all have a sense of system. And it isn't just one mind that's going to understand and, you know, take part in every single design decision, because really everybody has to be a part of that for themselves. So, you know, objectives, you know, for software and systems engineers, question is, what do they need to know? But perhaps more importantly, how do they need to think? And what do they need to know how to do? So this is really a practicing skill. So what sorts of tools do they need to know how to use? How do they use those tools and work with other people? So really, it isn't just what they know, but how do they think and how do they work those issues? So if my time, I'm running over schedule. Okay. Okay. So V&V is critical. That's it.
Teaching systems engineering in Cranfield University is what I do for a living. It pays the bills. Being an INCOSE associate director and helping to organize this thing is what I give back to the community and allows me to come to these kind of meetings. The thing that I actually like to do and would like to find someone to pay me to do forever is the systems engineering body of knowledge, reference curriculum work. I'm going to talk about my position statement, which is in my paper on the website. I said two things, really. I said that as an absolute minimum, and it's fairly obvious, I think, we need to educate systems engineers to understand software engineering, software engineers to understand systems engineering. I'd like to go further than that and suggest that potentially we ought to educate them together in some kind of joined up lifecycle engineering process. And that would be the real aim if we could get there and if we knew what that was. So I want to talk about education and real world practice. And we can teach people certain things. You can learn certain things in education. You can learn knowledge and skills, and you can learn softer skills. You can learn how to research, how to learn. It's a fairly benign, controlled environment where you're allowed to fail. In the real world, you learn how things are really done. You learn the knowledge you need to do the job. You learn how your organization do things, and you learn the skills of professional practice, communicating and working together. But it's a much harsher environment, and failure is really a difficult thing. And those of us who survive failure learn, but that's not really a great idea. So how can we bring those two worlds together a bit more is really what I want to talk about. And my premise is that there's a certain kind of graduate master's education, professional master's education, which to some extent spans these two worlds. We can talk more about the domain technologies and ideas to do a particular job. In particular, we can do education in the context of life cycle and solving problems. And we can set the foundations for these professional skills. This works best when the education is linked to the needs of professional bodies and organizations and practice. And it works best when we give students experiences that are rooted in real world practice. When we give them guest speakers and mentoring and case studies and capstones and foundation projects. We can't try and pretend that education is real world practice, but if we can bring the two together, we can get real value from that. The problem is that we have a pipeline for professional software engineers, which has professional software engineering masters and experiences and brings them into jobs as software engineers. And we have a pipeline for professional systems engineers that does the same things. And what that does is creates the wall we've all been talking about. And it creates it in academia, and it perpetuates through into practice. We don't want that wall to be there in practice. We want multidisciplinary teams, but we find it hard to achieve it. What we would like to have as a minimum is to have software engineering degrees and systems engineering degrees which teach an awareness of each other and which teach these shared foundations of practice, how to work together in multidisciplinary teams, how to understand each other's thought process and the ways of working, how to work together better. And if we can do that, we can put them into organizations where there are communities of systems engineering practice, communities of software engineering practice linked to professional skills and development, that people work in multidisciplinary teams working together. And we can have shared experiences in the educational world that match the shared experiences we want people to have in the real world, but we can still graduate them and train them in their particular discipline and their role in that world. That all seems self-evident, and that's the sort of first step we need to take. There are two pieces of work that have been going on for the last 10 years to take us in this direction that I've been involved in. The Graduate Reference Curriculum for Software Engineering, which was produced in 2009, and the Graduate Reference Curriculum for Systems Engineering, which was published recently, along with the new Systems Engineering Body of Knowledge. Both of these things recognize that they're part of a life cycle problem-solving approach. They both recognize the importance of each other's discipline, and they both recognize that it's part of a professional practice where you're doing problem solving and working together. My second position was that if we can do that, can we transition to educating people together to work together in some kind of engineering across the life cycle approach? Because that's really what we want. We don't want systems and software engineers. We want the right engineering to be done across the life cycle to deliver value to stakeholders. Problem is, what does that look like? So what I eventually would like to see us move towards is to have degrees in professional engineering, life cycle practice that teach relevant systems engineering, software engineering, project and program management, foundations for shared practice, that teach this common life cycle approach and which allow people to focus on particular skills like architecting or modeling or writing software or whatever it is, safety, reliability, and that mirror the shared life cycle approach we could take in industry. If we had that view, I think the education piece would almost be easy. I believe that this is supposed to be tantalizing you to go and look at the systems engineering body of knowledge. I believe that we've done some things to take us in this direction. I believe that we've abstracted away the fundamental principles of life cycle as concurrent processes within a life cycle framework, applied continually and agilely to problems, applied at multiple levels and applied across multiple problems. So we started to understand the relationship between architecture and problem solving. That we began to understand where engineers fit in the enterprise. And we're trying to take that to a foundational principle that we can teach people, that we can then build particular models and approaches and techniques on top of. I think that's really where we'd like to get to. My final point, because I work in a university, is that all this sounds great, but getting our traditional academic organizations and structures to buy this idea. I've tried to have multidisciplinary projects, and the problem is you've got to assess each of the students against their own degree criteria. So if the project succeeds, but you were terrible in it, so you get a good mark. It's really difficult to do these things. And I think the only real answer for an educator is that if industry wants it, if employers want it, then the universities will have to provide it. Okay, so that's my position. And I think that takes us nicely, I hope, into my job as deciding which of the panel answer your questions. Thank you very much.
Thanks. One of the things I've observed from industry is that each time we bring students in and we hire them, we immediately retrain them. And I teach software engineering, and in reality, if you go to Google, you have a month or more of indoctrination and retraining. At AT&T, old Bell Labs, we've had the same thing for a long time, and we still have it in the new AT&T too. I think the systems thinking and a lot of the base stuff is extraordinarily valuable. And I think the I's versus the T's, I's get rich, T's get promoted. Because if you're incredibly intense in a certain area, you often get rich. I mean, it may not be. And many of the things that I'm coming across in AT&T and in communications industry in general, and many things other folks are not your traditional defense project large things. They're not 4-year systems. And the 4-year systems, even our switches are going to become 10-year systems, 5-year systems, 2-year systems. You look at the rate of how mobility infrastructure changes, it's the same sort of thing. I mean, all this is markedly different from what I've heard. And when I teach it, Brooks still applies in most of these areas. But in terms of the processes and stuff like that, it's just not there. I think Bill made a big deal about, and I agree with him, reuse has won, right? There's huge reuse. And in fact, part of the craft of development these days is understanding all the libraries. But
I'm not sure there's a question there.
The question is, what part of this addresses it?
In fact, Anne asked me this question a couple of years ago. How do we select the right people to try and turn into system thinkers? And I remember talking in the bar about the systems engineering sorting hat, which I still haven't invented. Apologies. We do a 1-week course for our people in defense, in awareness in systems engineering, which is trying to raise the general standard, but we also use that as a selection mechanism. So the people who come on that week and get it are encouraged to do the later things. People who just come on the week and get some awareness still get some value. We try to use that short educational experience to steer people into a longer. Yeah. Thank you. There's a question here and then
there have been a number of references to the software engineering body of knowledge, the systems engineering body of knowledge, bookcase, I guess that's the way we were going to pronounce it, and various other documents. And so that raises the general issue of certification for both programs and also for individual professionals. And I think as we look at systems engineering and software engineering, systems engineering culturally and in its heritage seems more to fall in the ABET world. Software engineering maybe, how shall I say, less so. certainly my personal view, and now this is going to get dicey, is that software engineering is not credible by any serious ABET standard, whereas systems engineering, by its heritage, seems to be. And so I'd just like to get some comments from you guys in response to this provocation.
I was hoping nobody would raise the certification question because it always causes an argument. The reference curriculum that we produced in Bookcase along with our body of knowledge, we very specifically said was not for certification. It was for universities to help them raise the standard and breadth of their master's programs. But we still have the perennial debate, could it and should it be used for certification? And is certification essential for credibility? I'm not sure I know the answer.
I guess what I've observed is that the system engineers are sometimes envious of the software engineers. They have some kind of technical criteria that by which they measure whether they're accreditable or not. Did you have this the other way around? No. It's much harder to come up with a general set of things that system engineers know and do.
Even worse than, I mean.
I think we're all frightened of that question.
We can take it away. We'll have it all messed about that later.
So someone mentioned systems thinking, and I more generically maybe think about it as critical thinking. How do you teach that? Rather than, I mean, typically the way I view it being developed is you have lots of experience and you gain wisdom, and then you just know how to look at certain problems and understand that 3 out of the 4 possible solutions are traps, and there's only really one viable solution, even though on the surface it might look like there's a myriad of solutions. How do you, is there any way to teach that, or is it just something that you have to be born with, or do you just have to develop it after you've got lots of experience?
I believe, without any social science or background in this, but from my experience, that you can encourage it. And I think there's probably a minimum level of it that you can make people aware of, but I'm not sure how you make people good system thinkers. I think my argument that the way people have traditionally learned disciplines like systems and software engineering, which are largely applied and lifecycle based and about solving problems, is by going through the experiences of seeing it done well and seeing it done badly and getting the scars and surviving. I don't think we can really live with that as an answer. And I think we need the education to somehow accelerate and ease that process without ever pretending it can replace it. And I think systems thinking is a prime example of things that you can encourage in your curriculum, things that you can make students aware of, whatever their age and experience, but ultimately, you then either end up being good at it or just aware why you're bad at it. Probably the best we can do.
Speaking from an industry point of view, I think you can develop it, and you can develop it more quickly in integrated teams of people who learn from each other. You know, you can put a young person in with, you know, a broad group of people who have had that experience, and they can quickly see the impact of that capability and that learning, and they more quickly come up to speed. I don't know if you can learn it from a book, but I guess in an educational setting, if you work in teams, certainly in an industry setting, if you're working in teams, you can develop it.
I hope you can teach it because I teach that course. I believe you can teach someone how to be an architect, but I don't think you can teach them how to be a great architect. I think you can teach people how to be a systems thinker, but I don't think you can teach them how to be a great systems thinker. You can show them the different tools. You can have them work through different experiences. You can get them to a place where they have some level of competency. But I think, like architecture or strategic thinking, these are sorts of things that are based on someone's ability to abstract. To be a great systems thinker, you need to see the connections that other people don't see. You know, if it were easy, everyone would see it, and we wouldn't have this discussion about systems thinking. It would just be something you do. I do believe if we want more systems thinkers, we need to teach systems thinking in K through 12. I think if you look at I don't think you teach systems engineering and systems thinking, but I think if you look, for example, at social situations, what's the cause of the Civil War type of a thing, thinking about it from a systems perspective is going to be much more enriching than coming up with a list of facts and dates. And I think that kids at some age are able to sort of understand these types of things. They understand the relationships they have with other people and so on and so forth. And I think if you start to cultivate that sort of need to understand connections and relationships at an early age, you're going to produce some outstanding systems thinkers.
Another aspect of this part is that it's more holistic. Tries to think more about text rather than just the problem that's stated. And we try to address this a little bit in these project courses by saying that you're considering this client as their stakeholders. Go ask them who are their stakeholders. What are they trying to see? What kind of things are they going to be counted as successful for? That tends to broaden it.
So a couple of years ago, I wrote a paper called Teaching System Engineering to Software Engineering Students, addressing the undergraduate level. And I took the SE 2004, which is the ACMI IEEE curriculum recommendations for undergraduate software engineering. And the paper was how you could augment that curriculum. So a couple of things I suggested is add a course in System Engineering Essentials, add a course in Continuous Math with Engineering Applications, take courses like Software Design and expand it to Software and System Design, and so forth. And to add a specialty track in Software Systems Engineering. So the 2014 update to the 2004 curriculum is about to be released, and none of my recommendations made it, except perhaps to put more system engineering emphasis in the capstone courses. And the response was, these are all reasonable recommendations, but our curricula are so crowded already that in order to put in new things, we have to give up something, and there's nothing we're willing to give up. So my question to you, how do you take existing curricula and modify them so that both system engineers can learn more software engineering and software engineers can learn more systems engineering?
I think that the answer is that's very difficult. I think you can only do a certain amount of that, which is why that I think ultimately the only way we can go is to think about some kind of life cycle engineering and to educate people in that and to kind of try and fix the existing curricula to be a little bit broader. I think we can do some of that, and we are, but I think at some point we have to recognize this, the team sport played by a group of people with a range of skills. That's what industry wants, whatever their job title is, and if we can't educate people in that, we're not going to really succeed. And so I think at some point we've got to stop trying to fix the existing curricula and think about a new idea of teaching people how to play an engineering role across a life cycle as a generalist and as a specialist.
So I think I like the notion of foundation stone, quite frankly, because what you need to do, what engineers actually do is driven by habit and what they feel comfortable doing. And so if you give them an education process that's totally different than what you expect on the workplace, it's going to be difficult. They're going to try to fall back on those habits. I think if you take, for example, a foundation stone approach and it's based on sound systems engineering principles, they're going to learn that working through that as a course of what they're doing. It isn't going to be, we're now going to have a course on principles. It's going to be what they're used to doing. It's going to be part of the habit. It's going to be the way they work and the way they think. And ultimately, I think that's what you have to do with this.
Yeah. After 12 years of developing a course to teach people to learn to both think and act in terms of systems, which involves systems thinking and systems engineering,
and I'll focus a little bit. And I actually started here at Stevens about 12 years ago, but I've further evolved that. I've come to the idea that it's not just system thinkers, it's group thinking. And I think that's the thing that I've observed, is that when I'm teaching people and get them involved, by using the principles of systems thinking, you can get them to think as a group of people, both in case studies we do during the course, but then I also have a project-oriented aspect that they have 2 months after the course to apply the ideas from the course in something concrete. And they can do that in groups of up to 3. And I find that the things that evolve from people that are working together, they have really come up with fantastic results, and they've been able to produce both understanding and communication, which I think is the important aspect. So it's not individual group thinkers. And I will agree completely with Rick's statement that we must push that down into the educational curriculum. There's some great work that's done about applying systems thinking in ecological situations, which could be very, very, very productively used at the lower school years, as a matter of fact.
Thank you very much. I'm going to synthesize a question from your statement, which was fascinating. I feel I know you well enough to say that. Ralph, as someone who's a kind of customer for this kind of education, does that sort of thing scale up? Does teaching people systems thinking on manageable classroom problems, does that scale up to the kind of systems thinking that you need from people?
Well, I think it does, as long as there's a infrastructure back in the workplace that helps us take those concepts and build them into how we do work. But yes, having that systems thinking, having that built into the culture, the way people think, having them understand that there are certain things they need to do to get to a successful result, I think that does scale up. We just have to make sure it happens on both sides of the fence.
Thank you very much. I'd love to take more questions, and as someone said before lunch, the fact that there are still unanswered questions means we're doing something right. But we don't have time, so can you join me in thanking the panelists?